Okay, is everybody at the right spot? Because I know we're a little bit out of order. Okay, so today we want to talk about two types of angles. We have two very short lessons. We are at the foundations of trigonometry yet. You learned how to convert between degrees and radians, radians and degrees, how to sketch angles. Today we want to talk about very important types of angles, and they are reference and coterminal angles. So the definition you want to write down for reference angle is a reference angle is an angle between 0 and 90, so it's on the smaller side, and it's formed between the x-axis and the terminal side of the angle. We'll use that definition to then look at an example of what reference angles are from a geometrical viewpoint. If I draw an angle in the first quadrant, okay, this is the initial side, this is the terminal side, and so theta represents the reference angle. Whatever that measure is, that is your reference angle. But suppose I were to draw an angle and it ended up in the second quadrant. Say it ended up over there, okay? Which part of this angle is the reference angle? Again, it's the angle formed between the terminal side and the x-axis. So it's that angle formed there. That's the reference angle. Suppose you end up in the fourth quadrant, or the third quadrant, excuse me. Then the angle is right there. Never against the y-axis. Do not make that mistake. Always against the x-axis. Always work against the x-axis. And finally, if you end up in the fourth quadrant, okay, then theta would be right here. So those are the four locations that you can be working with when you're trying to define or find the reference angle. So let's look at an example. 215 degrees. Which quadrant is 215 degrees in? It is in the third quadrant. So I'll draw my angle. I'll place it in the third quadrant. That's 215 degrees. As I try to identify the reference angle, it is the angle formed where theta is. And how I would find that is I'd simply just understand that that's 180 degrees, and I would be turning to 215. So how many degrees past 180 do you turn to get to 215? 35. So therefore, theta is 35 degrees. That's what we have. We also have 5 pi over 3. What's different about that is in radians. If you'd like to place it in degrees, go ahead. Anybody know what it is in degrees? Pi over 3 is how much? 60, and 60 times 5 is 300. So if you want to convert it, that's fine, but you will also have to convert it back. I'll show you two ways to do this. So 300 degrees does place you into the fourth quadrant. We're looking for theta. So this is 300, and you'd be looking for 360, okay? So what is the angle formed between 300 and 360? 60. You need to convert that back to radians, so it would be pi over 3. The other way to do it, if you don't want to convert it, is simply look at it like this. 300 is the same as 5 pi over 3, and 360 is the same as 2 pi, right? How would you write 2 pi so that it has 3 as a denominator? 6 pi over 3. So what is the angle formed between 5 pi over 3 and 6 pi over 3? Everybody see that that would be 1 pi over 3? So that's the other way you can do it as well. Either way is fine. All right? So what you would like to do is start working on these. It says sketch the angle of standard position. And when I say that, just make sure you're in the general right quadrant. It's just to give you a visual and then determine that reference angle. Take about 5 minutes doing that. If you want to check the answer key, it is posted right here for you to take a glance at. I'll come around and check to make sure everybody can get started appropriately. Coterminals are angles whose terminal sides are in the same position. So suppose I have an angle of 105 degrees. Which quadrant does that place me in? The second quadrant. And that is my rotation. So I'm going to give you another example of an angle that has the terminal side in the same position, but is technically a different angle. And it would be this red angle. Notice how it's in the same position, but instead of going just to 105, we're going to go around more than once. You may know how I would calculate that angle. Yeah, so if you just take 105 and add 360 to it, you can tell you get 465 degrees. In fact, if you wanted to come up with another coterminal angle, what else could you do? You could add another 360, couldn't you? You could take 465 and add another 360. And we get 5, 2, carry the 1. I get 825. And you could come up with another one. You could add another 360 to it. And you could get 1,185 degrees. Does everybody agree that you could get an infinite number of coterminal angles? And not only can you get positive ones, you can also get negative ones. So the green one would be an example of a negative coterminal angle. If you want to guess how I could come up with that measurement? Yep, I could do 105 minus 360, which is negative 255 degrees. So you could just add or subtract a combination of 360 degrees any number of times. You're going to come up with a coterminal angle. Okay? So what I'd like you to be able to do is be able to come up with one that's positive and one that's negative for each one. So we're going to do one example together. We'll choose the negative pi over 3. So we'll do a radian measurement, and we'll choose one that is negative so we can understand that. So quick just pause and consider negative pi over 3. Tell the person next to you anything that you can at all about negative pi over 3 radians. Go. Okay, and we pause. Negative pi over 3, I heard people say what? Tell me something. 60 degrees, but it is negative, so negative 60 degrees. Wouldn't that put you at the same spot as, say, 300? And 300 is the same thing as 5 pi over 3. Notice how we've already found a coterminal angle by just about thinking of it in our head, right? So I'll first mark the negative pi over 3. If you want to convert back and forth, then you sure go ahead and do that. I'm not going to. I'm going to use the radians. So this is negative pi over 3, and I'm going to find one that's positive. So instead of the angle going down like that, the angle is going to come around like this. So I could take negative pi over 3, and I could, well, that's a really big negative sign. And I'm going to add to that, yeah, 360 degrees. I want to add 360. But we don't want to add 360 to a radian. We want to add 2 pi to a radian. So as I add 2 pi, just notice that they don't have common denominators. So a couple of you have already seen that that would be 6 pi over 3. And so if you take negative pi over 3 and add 6 pi over 3, you do get 5 pi over 3. So 5 pi over 3 is coterminal with negative pi over 3. Now, as we just talked about, you guys recognize that 300 degrees and 5 pi over 3 are the same. So notice how those connect. But if it's expressed in radians, then the final answer must be in radians. We're all good? All right, let's find another one that is negative. So we found one that's positive, and then one that's negative. You don't have to draw the initial one if you don't want to, but please make sure that you do another one that's positive, another one that's negative. So if we do another one that's negative, looks like I'm going to have to then, I'll be in the same spot, I'll end up in the same place. That's the definition, your coterminal. So all of these look the same. It's just I go around more than once in the opposite direction. Anybody know what I'm going to do there? Yep, Kenny? Yep, negative pi over 3, and I'm going to minus 6 pi over 3. I get negative 7 pi over 3. So negative pi over 3, 5 pi over 3, negative 7 pi over 3, those are all what we refer to as coterminal angles. You can then continue to add or subtract any combination of 360 that you'd like to. The last thing I would like you to just consider right now is this. Are the angles 1,000 degrees and 240 degrees, are they coterminal, yes or no? Talk with the person next to you. How could you even determine whether or not they're a coterminal? Talk, see if you can figure it out. Go. 5, 4, 3, 2, 1. Any confident people, yes or no? No, they are not. And if you were to work through it, you know, some people are like, I don't even know how to do 1,000 degrees. And I had a math teacher, was one of the worst math teachers I ever had in my life, but he told me one thing that was really important. He said, when you don't know how to do the problem, he said, just do the problem, which I thought was interesting. So 1,000 degrees, if I go around 360, then that would be 720, and another 180 would be 900. So that places me at 900. So that's 900, and then I would go another 100 more, wouldn't I? So another 100 more, that actually brings me over to this spot, doesn't it? So that's in the fourth quadrant. Is this in the fourth quadrant? That's in the third quadrant, isn't it? Now, another way in which some of you guys thought about is you said, well, I'm going to subtract 360. And when I do, when you subtract 360 from 1,000, you get 640. And if you subtract 360 again, you can see you get 280 degrees. So 280 is not 240. Or you could try the other way. You could add 360 onto this, and you get 600. And then add another 360, and you did 960. You're like, well, that's not 1,000. And I heard you guys talking about different approaches there, but all are valid approaches, but those are not coterminal. Everybody good? Okay, that's that. Got a couple minutes, continue working. Please do not fall behind in your work. You can see that the assignments are not necessarily that long or complicated, but it is the practice that we require. Tomorrow we'll continue to practice degrees and radians. And tomorrow, is anybody missing class tomorrow other than this one right here? And you? And you. Okay. Tomorrow, super duper important day. So make sure you follow up with the video. Okay.
The same would just be 0?
This one will be 90 because it's here to the x-axis.
Oh, you still have to. Oh,
Better?
yeah.
But 360 would be 0, yes.